Well, thanks so much for the invitation and the chance to come and visit you tonight and talk a little bit about TAPR. I'd like to talk to you tonight about an organization that I've been involved with for a long, long time called TAPR. And many of you think that, if you've heard of it at all, that TAPR was just about packet radio. And I'm hoping that by the time I'm finished tonight, you're going to realize that we are a lot more than that. And we do a bunch of cool things that you may not be aware of. So the bio's already kind of been read, so there's not much new on here. But the bottom point, I've been involved with TAPR for something like 25 years now in a number of different roles. And I've been mainly, as in terms of projects, a person who's done a lot of stuff with time and frequency related measurements. And TAPR has a fairly large catalog of products that are based on that. So we're an unusual radio club. And in some ways, we're not a radio club at all. We're really a research and development organization. We have members, and we want to have more members, and we reach out to members. But our primary activity isn't in having monthly or quarterly meetings. Well, what we want to do is help advance the radio art by being on the cutting edge of kind of anything that involves digital communications with a very broad scope for that. Our goals are to promote the technical side of the hobby and advance the radio art. What we like to do is provide hardware usually, and sometimes software, or more often firmware, that doesn't exist yet. These are things that you can't buy from other vendors. And in fact, once something becomes mainstream and other people want to start selling it, we usually are looking for the next big thing. So we are trying to constantly bring the state of the art forward. We also have a very important function of helping to spread technical information about digital radio topics through conferences, publications, and forums. We've been sponsor, along with the ARRL, of the annual Digital Communications Conference, and a predecessor of that since 1981. We've been at Hamvention since 1983 at least. We started a series of special interest group mailing lists for things like APRS and packet networking in about 1992. So a lot of what we do is kind of spreading the word about the technology. The organization was formed in 1981, and TAPR stands for Tucson Amateur Packet Radio. And that's entirely accurate, except that we're not in Tucson. Our board members and officers are in 8 states in Australia. One of our officers, our president, is in Phoenix, Arizona, so that's as close as we get to Tucson. Our products are used not just in amateur radio. In fact, we're in science and academia, and you'll hear a little bit more about that this evening. We do support packet, but we've also been involved with spread spectrum and FT8 and Whisper and other digital modes. And not all of the activities are strictly radio related. We have a very broad definition of somebody who wants to bring us something cool to turn into a product. We're interested. We're a 501c3, so you can make donations to us that are tax deductible. The dues are $30 a year, and they're open to anyone. Our quarterly journal, the Packet Status Register, is published online, and it typically is anywhere from 10 to 30 pages or so, with a half a dozen technical articles, most of which are very interesting. You don't actually have to be a member to get at the PSR, but we sure appreciate it if you would join. Our organizational structure is we have an annual membership meeting at the Digital Communications Conference, which is held every year in the fall, usually in late September. The membership elects a 9-member board of directors who have a 3-year term. The board of directors has 2 physical meetings each year. One is at the Digital Communications Conference, and it's an all-day event. The other is at Hamvention, and that's usually an evening. Since I moved back to Dayton, it's an evening at my place with pizza, where we try to talk some business in all the chaos of Hamvention. And I think this may be unique. We have actually had a continuous online board meeting going since the mid-1980s. with first CompuServe and then the internet, that we in our bylaws are allowed to do all of our business via email. And we've never been out of session since sometime in the early 80s. So we can do business whenever we need to by using email, and we take votes and everything else. Got 4 officers. President is Scotty Cowling, WA2DFI. Vice President is Steve Bible, N7HPR. And Steve was the president of TAPR for many years until just this last fall at the DCC, when Scotty and Steve swapped roles. And Scotty moved from VP to president, and Steve backed off a little bit. Our treasurer is Tom Holmes, N8ZM. And our secretary and also the editor of the Packet Status Register is Stana Horzepa, WA1LOU. I mentioned some of the conferences that we do, and so just quickly, we're at the ARRL TAPR virtual Digital Communications Conference. Was virtual in 2020 and 2021. We did it via Zoom and had a pretty successful meeting, but we will be in person in 2022, September 16th through 18th in Charlotte, North Carolina. And we are hoping that we'll be able to also make it available via Zoom as well. It's a little bit challenging to do that and make it work well, but our hope is that it will still be available to folks who are not able to come to the conference directly. We're at Hamvention every year. We have a forum on Saturday morning. I don't know this year what the time is going to be or the room. There also is an SDR forum that our folks are involved in, and a couple of others. There is a dinner Friday evening that TAPR and AMSAT sponsor jointly, and this year it's going to be honoring Bob Bruninga at WB4APR, who's the creator of APRS and passed away this past spring. And we have a booth in Building 5 at Hamvention, spaces 5009 through 5011. And this year, we're going to have our neighbors right next to us will be the HamSci group, and I'll be talking about them in just a minute. So I mentioned that we do products, and we are always on the bleeding edge and very much an engineering-led organization. Our goal is to provide kits and assembled products that you can't find anywhere else, and particularly that they enable new technology, something that's not out there before. And you'll see as I go through some of our history, the things that are now commonplace technologies in ham radio that we were among the first to be working with. We have a very strong bias toward open source hardware and software, and I'll talk a little bit more about the open hardware license that we developed. And our products usually start with somebody coming to us with an idea that they've brought to the level of being pretty much a finished concept and that need help in making it manufacturable, building prototypes, getting kind of the last 10% done where we have expertise and can help with that. We don't have a bunch of folks in white lab coats who are just waiting for someone to come with a cocktail napkin and say, gee, you ought to build this. We're really working to partner with people who bring us well-developed ideas, and we can help them get that last step from a fairly complete idea to something that can actually be manufactured. And we're always looking for the next big thing. So any area of technology that you're working on that's vaguely related to digital radio, and if you'd like to develop something that might be made available to the community, we're happy to talk to you and see if we can help. So our current projects and products are largely around HamSci. And if you're not familiar with it, HamSci is a really fascinating group. It's an informal group of academics, mainly space physicists. The founder and leader is Dr. Nathaniel Frizzell, W2NAF, who is a professor at Lehigh State. I'm sorry, not Lehigh, Scranton State University in Pennsylvania. And he has brought together folks who are working professionally in space science, which is understanding our ionosphere and solar effects and all the things that affect radio propagation, and getting ham radio to provide inputs to give the scientists better data to better understand what what's going on in the ionosphere with solar flares and all the various other things that happen. There we go. The first activity that they did was around the 2017 solar eclipse, where they ran a contest, kind of to try to work as many stations as possible, with the idea being to use the logs to see where propagation was during the eclipse. Because, for example, 80-meter propagation picks up around the area of totality because it acts like it's nighttime. And so they gathered up a huge amount of data, and there have been several peer-reviewed scientific papers that have been published using that data to understand the effects of the rapid transition from day to night of the eclipse and how that affects radio propagation. HAMSCI has received a very significant amount of NSF, National Science Foundation funding, to develop a ham science data gathering system, including something called the Personal Space Weather Station. And that's what TAPR has been involved with. We're doing something called the Tangerine SDR, which is the core component of the Personal Space Weather Station. And I just want to be clear, TAPR is collaborating with HAMSCI, but we are two totally separate organizations. We're working together and working together very well, but we operate separately, and one doesn't tell the other what to do. So the Tangerine SDR is a high-performance modular software-defined radio that can be used for a lot of different stuff. It's primarily designed for the HAMSCI Personal Space Weather Station, but we also believe that with some additional hardware modules, it will be usable for a Phase 4 satellite ground station. It has academic uses because it has SCR and FPGA technology. It's all open source and well documented, so it can be used for teaching. It can be used as a ham radio SDR. The original or the initial version of it is a receive only, but there is provision for a transmit module that can be added. It's going to be about a half watt, so you need an amplifier and other things outside it, but it does have the ability to be a complete SDR. Because everything's done in software, it's perfect for experimenters, amateur, non-amateur alike. It's usable for remote ham radio as a computer related system. It's perfectly integrated into an Ethernet communications network. And I'm sure there are lots of other uses that we haven't thought of yet. The basic idea is that there's going to be a motherboard that we call the data engine that's got a huge FPGA and a bunch of other support components, and you'll be able to plug three RF receiver transmit modules into it simultaneously. It also has a low-speed expansion interface for receiver and other technology that don't require a very high data rate, and that allows extra interfaces. And it has a GPS-DO clock module as an integral part, because the science that we want to do with this requires both very accurate frequency and very accurate time stamping. Every data packet that is received by the receiver has a timestamp, so you can compare different locations data and match the timing up very precisely. It has a built-in gigabit Ethernet switch to pump all that data out. The primary design and the overall project managers are president, Scotty WA2DFI, and currently we have a dual receive module for kind of the 100 kilohertz to 60 megahertz a range that is finished, and we have some prototype hardware in hand. Tom McDermott N5EG is the primary designer of that. There's also a specialized very low frequency receiver that's intended for things like capturing spherics, which are these strange atmospheric events that cause noises at extremely low frequencies. And Jonathan, KC3EY, is leading that. The clock module is called the CKM, and that's been my bit. I've done the primary design work on that. And there's also a magnetometer, which is something that the space scientists want, because solar activity and other ionospheric events can change the magnetic field of the Earth. And with a whole bunch of magnetometers spread around, we can learn a lot more about how those things interact. So David Witten, KD0EAG, is the primary designer of the magnetometer. This is kind of a block diagram of the system. As you can see on the left, we have the slots for the RF, receive and transmit, the gigabit Ethernet, the magnetometer, and then the data engine can go directly to the internet, and there's going to be a massive public database run. I'm not sure where it's ultimately going to be hosted. A lot of the development's being done at the University of Alabama in Birmingham to upload this raw IQ sample data of atmospheric events so that the scientists can then download what they need to explore interesting things that happen. It will also talk to a local client computer that can be used for local display. You could have Whisper or FT8 receiver or communication software running. And this can be a dedicated single board computer or a desktop. So there's a local use. The ham could use it himself, but it also makes the data available on request to the scientific community, which is something that's just never really been available before. This is showing the bits that the TAPR is really working on. Again, the server, the data engine, and RF modules are the Tangerine SDR itself. The GPSDO is actually a separate project because it will be used in this, but also it has other standalone uses. And the magnetometer design on the left is the independent project that plugs into the data engine, but it also can be used directly with a Raspberry Pi, and it can be used independently of the whole personal space weather station. If you're interested in doing experiments with the magnetometer, you'll see in a moment that there's actually a very low-cost system that is going to be available very shortly to do that. So this is the GPS module that I've worked on. We're calling it the SynthDO because it's a GPS DO that's coupled with a synthesizer that can do up to 10 separate outputs programmed in frequency anywhere from 100 kilohertz to over a gigahertz. And this thing is about 40 millimeters square. You can see the 3 SMA connectors to give you an idea of the scale. It had to be that small to fit inside the Tangerine SDR system. So it plugs directly into the Tangerine. We're also, though, going to have a standalone version with a carrier board that will provide access to all the 10 outputs and the other goodies on the system so that it can be used for time nuts or experimenters who want to, for example, generate a synthesized signal to feed into their IC 9700 for VHF use, is just one example. And then this is the magnetometer that David has been working on. Currently, the magnetometer module itself is on the bottom, and there's also a companion that plugs into a Raspberry Pi, and they connect to each other via Cat5 cable. You want the magnetometer module to be buried somewhere out in your backyard. Right now, we're manufacturers getting ready to do manufacturing of this system, and will be available very shortly. The biggest problem probably will be the difficulty of getting a Raspberry Pi these days. Hopefully, one of these days that problem will improve. So that's the other separate product that's coming out of the Tangerine SDR project. What I'd like to do now is take you through what TAPR has done over the last 40 years to give you an idea of the kind of things that we've been involved in, and where, again, we've done a lot of things that people who have heard of TAPR only in this context of packet radio probably aren't aware of. And of course, we started with packet radio. The original TNC1 was done when TAPR really was a Tucson-based group of hams who developed that first packet TNC that was more than kind of a breadboard. And then shortly after that, developed the TNC2, which we produced as a product for a short time, but we licensed it to MFJ and PACCOM and I think about 15 other manufacturers. So for example, if you ever used an old MFJ 1270 TNC, that was a TNC2 design that was licensed from TAPR. So in the early days, we were in fact packet radio. And not a whole lot later, we were supporting APRS. Bob Runinga, who unfortunately passed away earlier this year, introduced the APRS software at the Digital Communications Conference in 1992. and Bob and other APRS developers shared our booth space at Hamvention for many, many years. So we were very heavily involved with APRS. In the early days, we had some APRS-related products that we sold for a while as well. We were also involved with packet radio in standard setting. AX25 was developed actually by AMRAD, which is another group in your area, the amateur radio, I think it was Amateur Radio R&D, I think was what the AMRAD stands for. Very active group led by Terry Fox in the DC area. MACA is a packet radio protocol that Phil Karn described in 1990, and his presentation was used when somebody tried to patent the MACA protocol. We were able to throw the patent out because Phil had talked about it previously. And in 2000, we published the APRS protocol reference specification that has been used to help make sure that the APRS programs will interoperate with each other. So moving from packet radio, we were also involved very early on in spread spectrum radio. In 1996, Tom McDermott and some others developed a frequency hopping spread spectrum radio that was a truly advanced design. It would have allowed 30-mile kind of communication range at 128 kilobits per second or so. But unfortunately, all those big chips that you see on the board that's on the left were made obsolete by the manufacturer shortly after we put them in the layout, and we were never able to get parts that we could use to finish the project. So it was early, but it was unfortunately not something that we were able to finish. But not all was lost, because Tom N5EG, who is extraordinarily knowledgeable about digital communications, wrote a book called Wireless Digital Communications Design and Theory that TAPR published. And this has been used in a lot of like junior college type EE classes in many places as the textbook for digital communication basics. So we're very proud of Tom for that, and it's been a big success. In that same kind of time period, we also had our first steps into GPS. Tom Clark, K3IO, who used to be W3IWI and lived in the Baltimore area, and unfortunately he's another silent key recently, professionally was involved in very long baseline interferometry with radio telescopes, where you need to have telescopes that are thousands of miles apart, synchronized extremely closely in time. So he developed a board that was called the Totally Accurate Clock, or TAC, which also stands for Thomas A. Clark, that took a Motorola GPS module and made its pulse per second signal available. And Tom and Rick Hambley worked on software to run on a PC to get that data. And in the upper right hand of the picture, or corner of the slide, is a picture that I just love. Back about 20 years or so ago, my job let me do some international travel, and I had a couple of chances to go to Australia. And a ham friend there, who's also a TAPR board member, Daryl VK2 TDS, and I went to the Parkes Radio Telescope out in the middle of a sheep field in Australia. This is the gigantic, I think it's a 210-foot diameter dish you may have seen pictures of. And as we got the tour of the place, and because Australia is a strange place, Daryl knew the brother of the chief engineer at Parkes, so we got the engineers tour. I saw this monitor, and this was running the Tom Clark, Rick Hambley software. So they were using the TAPR Totally Accurate Clock as part of the timekeeping at one of the largest radio telescopes in the world. And I always thought that was just kind of cool. Another application of GPS is for precise location. And back in the old days, there was a differential GPS idea where you could improve the accuracy if you had a local base station that knew precisely where it was, and it would transmit data to other GPSs nearby that would show the difference between where the GPS said the base station was and where it had been surveyed to be. And that would allow you to get down to maybe 5-meter or so accuracy within range of the base station. We developed a board that did that function. Doug McKinney, KC3RL, was the primary designer of that, and unfortunately he passed away in 2006. Steve Bible was also involved. So we had a couple of GPS-related activities going on quite early in the history of GPS. Then we started moving towards software-defined radio. In 1999, Johan Forer and Steve Bible and Lyle Johnson found a Motorola digital signal processor evaluation board module. So now we get into the time and frequency stuff seriously, the time nuts. I've been interested in this stuff for years and years, and when I first started laying out circuit boards, I was making things that I wanted to use for my frequency measuring, and that turned into a whole bunch of different things here. I won't go through them all, except that kind of everything I've ever designed has turned into a TAPR product for some reason or other. In 2007, we did the open hardware license, which I was also involved with because in my previous life, I was an attorney because I couldn't find a reputable thing to do. So when we were doing some of our software-defined radio work, the developers wanted a way to do hardware projects with the same kind of community sharing that the software world had. So we worked with a number of other lawyers and folks in the open source community to put together the open hardware license, which was one of the first hardware-oriented licenses. There are a few others, and it's been used in quite a number of projects by folks other than TAPR. So we're very happy to have been able to contribute that. So now, what we think is the first true ham SDR was the Open HP SDR, and starting in 2009. And this was a high-performance software-defined radio with direct sampling, and basically, when it came out, it was as good as the best HF radio available anywhere. The various generations of it ultimately turned into a single board called Hermes, and Apache Labs, if you're familiar with the NN radios and Apache Labs, those radios originally started from our Hermes design, which was open hardware, so they could do that. And this was the first use of the open hardware license. We supported David Rowe for doing digital voice without patents, a patent-free codec, which can do amazing quality speech even on narrow bandwidth HF channels. So we're very pleased to have been able to support David. We support whisper beacons. We have modules for using a Raspberry Pi to generate or to create a whisper transmitter on, I think, anything from about 80 through 10 meters by either Zoltan HA7DCD or Bruce ND8i. Those are available in our store now. This was my biggest time nuts project. It's you can think of it as a stopwatch that has 60 trillionths of a second resolution. And things like that have been available in the past, but they tended to cost $20,000 or so. But ours cost $200, and it's built on top of an Arduino. And again, all open source. We sold about 500 of them, and they're used by universities and national research laboratories and time nuts everywhere. So what's next? Yeah, it's up to you. What do you want to do, and get started on it, and we can help. And I'll just finish up by going through a couple of our alumni and awards to show that some of the folks who've worked with us have definitely made good. Matt Edis, N2JMI, was a student when we ran a paper contest, a student paper, and he won that award and presented at a software-defined radio seminar at the DCC back in something like probably 2003 or so. He went on to create Edis Research and develop the USRP, the first software radio appliances. And that company was later bought by National Instruments, and it still is very much in business today. So Matt was very active with TAPR early on. We were able to support him, and we're very proud of that and very proud of all that he's done. Gerald Youngblood, K5SDR, was the founder of Flex Radio Systems. You might have heard of them. and he published an article in QST called "A Software-Defined Radio for the Masses." That hardware was first shown at the DCC in 2002. And in the lower right-hand corner is the three-board stack was that first radio. And from there, he went on to build flex radio systems and the wonderfully monstrous, powerful software-defined radios that they now sell. He gave a talk in 2014 at the DCC about how flex radio came about. That's available on YouTube, and it's a very interesting talk if you ever get a chance to look at it. We have won a lot of awards at Hamvention. Folks that have been involved with us starting in 1984, Lyle for the original TNC, Bob O'Geyer, Bob Runinga, Peter Martinez, who developed PSK31, Steve Dimsey, who has run the APRS Internet Project, Tom McDermott, who's basically the guy that I want to be when I grow up. He's designed all sorts of incredible RF hardware. David, who did the software or the patent-free codec, and Stana, who has been a prolific ham radio publisher for many, many years. She was our most recent winner in 2016. So a lot of our folks have gone on to make good, and you may know their names from other areas. Bob McGuire's been very active in AMSAT, for example. So we have been at the core of innovation in ham radio for a long time now. And again, what can we do for you? We are happy to provide presentations. We're happy to provide conference papers. Our conferences are all available either in person or they're ultimately streamed on YouTube. And I thank you very much for the chance to talk, and I'll answer any questions.
Fantastic. Thank you so much. Really, really fast questions. Any questions for John?
Thank you for your presentation. My name is Mike, WA8AHZ. Could you comment on the future of cognitive radio and sped spectrum as it might amateur?
Yeah, cognitive radio is a fascinating thing. It's the idea of using software-defined radios to sense their environment and figure out, for example, where is there an empty chunk of spectrum that I can use to talk to my other station, 30 miles away in this direction. And you get much better spectrum efficiency because you can use space as needed rather than having it devoted for all time to some single activity or licensee. And it's a very powerful concept. It's taken a long time to get going, but it's coming along. And Bob McGuire, who I just mentioned, has been involved with a company called Hawkeye 360, which has been very active in that. They have launched a bunch of satellites that are in orbit, and they monitor terrestrial RF. And for example, when the Russians were getting ready to come into Syria a few years ago, their satellites actually saw the communications build up at the Syrian border as that was happening. So it's very powerful stuff. Hams aren't doing a whole lot with it in ham radio yet, but hams are definitely involved in developing it. And I think we will be seeing those applications as time goes on.
All righty. Well, thank you so much for joining us this evening. It's a terrific presentation. With your permission, we post these on our club YouTube channel and make them available so that we can share and spread the information even more widely. One of our colleagues, I think he has 5 of your pieces of hardware in his shack.
Well, I think I've designed 9 products, so he has to buy some more.